In question 3, trying to get back to the space station, you just need to remember that you would throw the camera in the direction opposite to you. So if the space station is over here and you want to get back to it, you would throw the camera away from the space station and you would be moved in the opposite direction back to the space station. In number 4, we have this rocket, and since the change in momentum, delta mv, is equal to 1.2 times 10 to the 3 times 5 times 10 to the 4, or 6 times 10 to the 7 newtons, and it tells us that the force of gravity pulling downward is 5.8, that will be enough because we have 6 times 10 to the 7 acting upward and 5.8 times 10 to the 7 acting downward. So the difference, or F net, is equal to 0.2 newtons in the upward direction. Enough to get you going. In number 5, we have a 3.2 kilogram cart traveling 1.2 meters per second, and it collides with a stationary one. So m1v1 equals m1 plus m2 times v2. The final velocity is the combined velocity of the cars because they lock together. So 3.2 times 1.2 equals 3.2 plus 1.2 times v. Rearrangement gives you v is equal to 0.77 meters per second in the forward direction, obviously. Question number 6. A bullet is fired into a steel wall with a velocity of v. So we already know that it has momentum mv. This is actually the change in momentum as a result that it's going to deform, or it's going to stop. And so since the change in velocity